Hello. And here is the screen of the Commodore 64. I'm sure everybody knows what this means. So we will load the directory of this disk. And the one thing that was always bothersome about Basic 2, which this has, even though it should have had a better basic, is that if you were writing a program and then you decide you want to load the directory, guess what? The program is gone. So I'm sure there were a few people who had catastrophes, but hopefully only once. So these are musical things. They are. But we're not, at this moment, going to load any. There is something that I have often done that if you have a 1541 that just doesn't seem to want to read, one quick thing you can do is to initialize it. And some computers that means format. This is not formatting. This is initializing. And on the Commodore 64 in Basic 2, you open 15, 8, 15, quote, I0, colon. And then you, of course, just like if you open a door, you must close it. You do that. Now what this does, it forces the drive to go out and look for the directory and other such things. And if it can't find it, it also forces it to bang the heads. So, and here's what happens sometimes. Sometimes drives just get out of whack, a little wonky, who knows why, and they just won't read. But there's really nothing wrong. All you have to do is force them to do that command, and they will go out, and the head will bang. And you'll know if it was successful if the error light stops flashing, and then you can load the directory. And if it was not successful, nothing will have changed, and there's something else wrong with the drive. So another cool thing I like is that, if you want to just move up and do that again, you can do that over and over and over. Another quick thing you can do if you want to sort of torture drive to see if you can wake it up is you can add a line number, and then you can add another line number. And then you could say run. Oh. Aha. Right. So the reason it said that is because the directory is still in there. So we're going to new that, but then we can just go up and we can go boom, boom, and run. And now the drive is flashing because it is initializing over and over and over. It's funny because I remember when I was first taking computers, I was talking to me, well, we'll have to count how many this and count how many this. No, you can have the computer do that. So look at this, 15, x equals x plus 1. Oops, that's not the plus. I shifted when I should have. 15x equals x plus 1. And then we printed 17. Print x. And then if we run it, it'll tell us how many times it's forced the drive to initialize. We can also, if we stop that, stop. We can look at the program. I think this will work. No, I think semicolon. Let's try that. And it will print them, well, not always exactly lined up, but somewhat lined up across the screen. So right now, in very short order, it has had the disk drive initialize, coming up on 100 times. Now this drive, of course, is quite happy, so it just keeps flashing the light, probably thinking, why are you doing this? I'm fine, I'm really fine. I am fine. let me try. I will break this. I think my first inclination was to put, oops, it's alright, to put a comma in there. I think that does something different. Oh yeah. That's kind of neat. So there, the drive is initializing. Is that Mr. Andrew?
Yeah.
Andrew? Huh?
Where's Mommy's phone?
She has it.
Oh. Oh yeah.
She is over minding Nana.
Daddy, are you making a video?
Yeah, I'm just filming the screen though. Like I'm just filming the monitor.
Okay.
Okay, I'll be done in a moment. I'll come up. Another thing we can do, we can add something else here. We can put in a cursor movement. That cursor movement means that this will be printed at the top of the screen. Let us list this again, this quick little program. The other thing we're going to do is that heart thing clears the screen. So right now, and this should make it all run faster too. Let us list again. So the first thing we're going to do is print. To clear the screen, we're going to open and initialize and close, and x equals x plus 1. Print. Oh, why do we have another print there? No. Excuse me. We will bring this back over here. So if I've done this right, it should clear the screen, do the initialization, add to the x, not clear the screen, but take the cursor to the top of the screen, and then print the x, and then it should go back and go back to 10, not 5, go back to 10, and do it all again. And we should see this march along. I think you can see that. You know what? I'm going to change that, because that is not the best location. I am going to change this. So I'm going to add some spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to go down. And then, those are cursor movements. I'm going to run it, and now it's going to print it at the side of the screen. And it's chugging along. I don't know if it's actually any faster. But you know what else we can do? If we are so inclined. We can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And we're going to add some cursor. Once again, more cursor movements. The S moves it to the top of the screen, the Q down, and the bracket over. So now, in short order, we have a program that will initialize, will clear the screen, initialize, add to X, and then print it pretty much in the middle of the screen. And it'll tell us how many times it's done it. And you know what else we can do? Say we decide that we, say in line 18, if x equals 100, then print, quote, all done. So, if we run, it should now, oh, you know what, I think, though I have erred in this, I think it's going to print all done, but it's going to keep right on going, because I didn't tell it to stop. I didn't send it to an end. All done, and it carries on. See how these are, hang on. Colon. I think end works. Does end work? Okay, run again. This disk drive is probably thinking, why can't they just leave me alone? So, this will keep running, and it will keep counting, and the disk drive keeps flashing, and this time, when it gets to 100, it should say all done, and then it should come up and say end. Right, well that went well. What have I done? Oh, right. Alright, almost there. I did not, somehow I wiped out the quote, did not close the quote, did something. You can quote me on that. So now, the disk drive is spinning, the disk drive is happy, the disk drive is initializing, and boom, 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 we're marching along, and now, it should come to the end and say, all done. So there, in no time at all, we have written a quick program that will basically torture a disk drive. But generally speaking, with this initialize command, it either works or it doesn't immediately. So if you do just one of these, if it's going to fix it, it'll fix it. If you're looking for a way to just sort of, I don't know, make the drive do something, then this would do. On occasion, you know, I have occasionally tried to torture a drive into coming back to life by doing this, you know, hundreds of times. And generally speaking, from what I can remember, it really doesn't very often do anything except make the drive bang some. So, is there much use to this little program? Not much. But you know, it's a funny thing, because when I first showed somebody a printout of a thing that I had done after I had discovered cursor movements, and I showed them the listing, and this fellow was not stupid. He said, "What are those?" And I said, "The cursor movements." He said, "Well, you didn't write this program." I said, what do you mean?" I said, you couldn't have done that. It's not, you couldn't have. I said, "Oh, yeah, no, it's just, you just put it in the quotes, press the cursor key, and up it comes." And that way, you can put something on the screen exactly where you want it, especially like by doing the first thing in line 5, when you do the print, quote, shifted clears home, and a quote, that will clear the screen. But when you just, like in line 17, you do the clear home without shifting, it does not clear the screen, it just puts the cursor to the top corner, and then you can tell it, you can move down however many you want, you can move over however many you want, and so if you have different things printing at different places, let me see if I can do this here. I suspect I can. Let's say y equals y plus 1. Oops, got that wrong. Don't shift. Okay, we're running, you know what, I often don't put in enough line numbers or spread them out enough. So we got y equals y plus 1. So now, we're going to change 18 to 19. And then we're going to go up, I know this might look a little strange, it's alright. We're going to go up to 17, change it to 18, and we're going to add in a couple of space. This is done with a shift, insert, delete key, and we're going to go down a couple more. And then we're going to go zoom, 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 zoom. And we're going to go Y. Why? Why not? So now, when we list, it should show that we now can count both X and Y, and we can print X and Y. And they'll always be in the right spot. And once it does it 100 times, there we go, then it will stop. So away they go. Zoom, 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 zoom. So, if you're doing something and you want something to always be in exactly where you want it on the screen, use cursor movements. Before all this, you know, people would try all kinds of things, but it's really simple. It's really magical. And, you know, you could put in spaces, but that will wipe out other things. This just pops it right where you want it. And from what I know, if there was something else on the screen, it wouldn't mess with it, because it just puts it exactly where you want it. So, to summarize, what have we done? In line 5, we clear the screen. In line 10, we initialize the 1541 disk drive. In line 15, we add 1 to X. And also 1 to Y. Oh, now if we were really good programmers, look at this. Line 2, we should do this, of course. X equals 0, colon, Y equals 0. I remember getting programs back when we would send things down on cards, and it would say, often give an error. I'm not sure what language was working, because we hadn't set things. When you start at nothing, they start at nothing. So you don't really have to set them at nothing, but it's best to set them at nothing. So there, X is 0, Y is 0. Now we print. So now we clear the screen, now we initialize the drive, then we add 1 to each one. Then we print X, then we print Y. And if X is equal to 100, then print all done. And then we end. Otherwise, we go back to 10, and we do it all again. Now, if we put those X and Y things in the wrong spot, about 0, and where we had to go to going back to 2, we would keep resetting to 0, we would keep clearing the screen, and it wouldn't go well. But, thankfully, we don't. We go back to 10. So, here with our improved program, which actually does nothing different than it did, it will count, and when it gets to the end, it will say, all done. Boom. Isn't it magic? Now, of course, another thing we could do, we could say, you know what? Y is equal to 10,000. Is this going to make any difference? Well, it's going to print different. But Y hasn't, it's counting. It's now at 10,027. Sort of like, the guy doing push-ups in the gym going 1, 2, and then somebody walks by and he says, changes it to 187, 188, 189. Anyway, so there. It's still going to stop at the same time. It's really only counted from 1 to 100 twice. But we just changed the value of Y. And if we want it to appear that we've tested it 100 times, but we're not going to. Oh, now here's something. If I set that at 500, guess what? It's never going to stop. Watch this. Because it's going to just keep counting. That is because I said if it equals 100. So maybe I should change it to if it's greater than 100. So if I run it now, it's just going to say, boom, all done. So these are the kinds of cute little things that I remember learning when I was in high school on, not a Commodore 64, but yes, an 8K PET. These are the kinds of things that we would do. And we also used a tape drive. So when we would save them, it was exciting just to watch it say saving. So there, so as you are tinkering, keep in mind that there's all kinds of cool things you can do. You can write little programs. That's how we started back in the pioneer days. Every meeting, every T-Bug meeting was an adventure because somebody had done something that no one had done before. There's not so much of that. I'll mind you, they say, everything's been invented that will ever be invented and we're fine. But then, here comes another iPhone or another this or another that. There's always something happening. But when we would go to T-Pug meetings, there would always be some sort of magic. And that was part of the allure of it all, the magic. What has somebody done? What has Butterfield done? What has Punter done? What has Brad Templeton done? There's David Hook up in the back copying discs. What's on the disc this month? It was an exciting, pioneer, magical time when computers were young. And really, like like I told you, I put in those cursor movements, and this fellow of great intelligence was baffled as to what it was that those meant, how I could have put them there, why I would put them there, and it was convinced I hadn't put them there. But I had put them there. So there we have it, a quick little basic program. Oops, excuse me. Well, that's fine, it's still 0. That will torture the disk drive. And count the push-ups, so to speak. And it is, of course, much more impressive to say that I've done 10,000 push-ups than 50 or 60 or 70 or whatever. Anyway, the drive seems quite happy. It's funny, when you do the initialize command this many times in a row, it actually looks like the drive has an error because it just keeps flashing and flashing and flashing. But then it stops. That's the way, if you ever issue this command to see if the drive is going to come around and work, is it'll sort of go off and bang the head, and then very quickly the light goes off. And you're like, oh, cool. And then you can probably load the directory and everything. It's fine. If it keeps flashing, you can try doing it again. You can write a little program just like this. This program here to torment and torture it. I don't think it'll make any difference, because generally, if it's going to work, it works. And if it isn't, it isn't. Like I was working on a disk drive the other day, or looking at a disk drive the other day, and it was doing nothing. It was spinning, it was doing its thing, but it wouldn't read anything. So of course I tried this. I think I tortured it some. It didn't, the first time didn't work. It typically isn't gonna. And that is, I suspect, probably the head is what is bad. I think. If you remember, I did isolate it down to, basically there's 3 things. Power supply, drive mechanism, circuit board. Circuit board was fine, drive mechanism, the power supply was fine, so it must be the drive mechanism. And it was one of the flippy doors, and according to the thing I was reading online, who suddenly the name I don't remember, but the guy who builds power supplies, says that there are a lot of failures with the heads on the Neutronics drives, which is too bad, because I don't know why, I still like the turn down flippy doors better. I do. I just do. So there is our program to torture a disk drive. Count how many times we've tortured it, but only do it 100 times. And then proclaim, well done, woohoo. So there is a quick little basic program. It's funny, I remember seeing demonstrations at TPUG meetings that were not much more than that. Just little quick things about what you can do, how you can do it. And just little things that people have found. Because, I wasn't in right at the beginning, but fairly near the beginning, or TPUG, but certainly in the computer sort of getting there days. And the original manual that came with the first PET, it was either 16 pages, maybe 32 pages, maybe. I don't think it was 8, but it was small. There was really nothing to it, considering all the things that there are, the magic of inside the PET. Now, the Commodore 64, they had realized, okay, we got to do better. But these days were exciting. Everything was new. Every subroutine, there were pokes, there were peaks, little routines, programs, all kinds of things. And people would come to the TPUG meeting, and we had, I swear, literally, there were hundreds of people that would show up on a weeknight at a high school in an auditorium. And we had a big projector. And it would somehow hook up to the PET, and there up on this screen would be much like what you see here, except of course it was green. And people would sit there and watch. When I was in Florida, we did something different. We did not have hundreds of people, but we might have 30 or 40, and we had a thing where we could broadcast what was being seen on the monitor of the Amiga, and people would bring their own little portable televisions, and it was a bank room. It was like a community room, and it had a whole bunch of permanent sort of desky things there. with all kinds of power things, and people would come in with their television, not a big television, but just little, I think maybe 13-inch ones, and plug in and tune into the right station, and they could just sit there and watch exactly right in front of them what was going on the screen. We were great innovators. Kind of like the first Wi-Fi, but not really. But anyway, it's amazing how many people, to see everything, like we would have other monitors, we would have things facing the people, but still, it was really great to have people being able to sit in the back corner and see exactly what was going on and hear what was going on and learn what was happening. So there we have a quick basic program that doesn't do much. There it is in lowercase. And does it change anything when we put it in lowercase? Nope. It still runs exactly the same. To put things in lowercase, you just press the Shift Commodore keys together. I guess the only thing is it's going to print all done in small letters. I guess. All done. And when we list it, oops. There it is. The one thing that is different is, well, I'm going to shift it back. See the line 5, print, quote, and then it comes up with a heart. When I shift downwards, that's a capital S, and the other things switch to the lowercase letters. Really, it's up to you, whether you work in upper and lower, whatever, I suppose. If I wanted to, I could come over here, say all done. And maybe, we're almost, I'll put in an exclamation mark. And is there anything, I know, if I do the shift now, the graphics characters come up rather than the regulars. So now if I run, it will count just as it counted before, and it will do its thing, and the disk drive will flash. And it will then say, all done, in upper and lowercase with 3 exclamation marks. And that is all I have to say about that. Bye for now.